announcements. Okay. Now this first one is pretty appropriate right now, after the first test maybe. They sent out a thing on when the tutoring schedules are. Let me go over tutoring. I'll first do Bessemer campus, then we'll do Birmingham. Here on this campus, we have at least 2 tutoring centers. Okay, one's right down the hall here. As you look out down the hall, you'll see 2 exit signs before the end of the hall. There's a third one down there. The first is stairwells going down to the left, and the next one's a second set of stairwells. The second set of stairwells to the right from that, rather than going downstairs, to the right is room 202. That's the Student Support Services Tutoring. And let's see if I have that with me here. I don't think so. But Miss Cicely Martin is a faculty member here, developmental math, but she is very good at every level of math. And she's in there certain days and times during the week. Not constantly, because she teaches classes here. She teaches classes on the Birmingham campus. I think her heaviest days here in the lab there are on Monday, Wednesdays, but she may have some Tuesday, Thursday times too. But I know on Tuesday, Thursday she's over on the Birmingham campus most of the afternoon. So she may not have as many office or lab hours in. She is excellent. Okay, if you need help, she's a developmental math teacher, but she's well versed in all levels of math. Okay, they also have peer tutors, students who have passed with A's or B's, the lower level courses, and they're able to tutor those courses. And they have a whole series of them. Great place. Ms. Hollins is the coordinator for the tutoring lab, and she will help you get set up and find a tutor if there's one available. Okay, now, that stairwell we're talking about, that this is across from, if you go down that stairwell, go down a complete flight, half a flight and then another half flight, and then when you come out, do an immediate right, and that door right there is the Space Center. Okay, it's 105 or 107, I think it is, right? Something like that. I think it's 105. And down on the first floor, it's across the hall from where tutoring is up here, but the other side of the hall directly below that. And now that's what I do have the things on. On Mondays from 12 until 4, Mr. Tariq Lake, who was a calculus student of mine, so I know he knows his stuff, is available for developmental math tutoring on Tuesdays and Thursdays. I'm sorry, on Monday, from 12 to 4, okay? So you can get tutoring before you come to class or after class is over with. That's both Math 090 and 098. Now, there's English tutoring Mondays from 10 to 3, but I'll let you worry about that later. On Tuesdays on this campus, from 10:30 until 2:30, Mr. Etheridge Means, who is used to be an adjunct instructor for us, and now he's doing tutoring for us. So he's a professional. He's not a student; he is a professional, and he is tutoring all math levels there. So that's 10:30 till 2:30 on Tuesdays. That's all they've got in the Space Center for this campus. Okay, but up here in the Student Support Services, I think 5 days a week they probably have tutoring. And I bet you they have some available, probably not a lot, but some available in the evenings as well. So if you need tutoring, there's plenty of things available there. See, I forgot to pick up these two. Now, on the Birmingham campus, are any of you Birmingham students that you would need to know this? Okay, if you're not, if you are, you can come see it. They have tutoring Monday through Friday. Not continuously, but they have a lot more tutoring available there than we have here in the Space Center. Now, they have a couple of other tutoring things. They have SSS, Student Support Services tutoring for developmental classes, I know, And Mr. Jeff Harris is in that lab a lot. He's not in there constantly because he teaches just like Ms. Martin teaches. But he is in that lab some hours every day. And he's an excellent tutor, and it's geared mostly for developmental math. They also have on the Birmingham campus the STEM lab, that's Science, Technology, Engineering, and Math. That's B118. Mr. Harris's Student Support Services is the first door when you enter the C building from the B building. When you go through that little stairwell there, when you get into the C building, first room on the right. C1, I don't remember what number it is, 106 or something like that, maybe 104. Something like that, first one in. If you're coming from the library, it's the last one on the left. Okay, so that's where that one is. Now, there's Space Lab, that's in the Leon Kennedy Center, the Student Center that's across the loop from the A building and the D building, the library building, where the cafeteria is on the first floor. On the second floor is the bookstore and Space Center, so you can go there. Now, B118, that's in the academic building. That's the STEM lab. Now, I don't know the exact hours, but it's open just about most of the time during the day. And I don't know when their tutors are available, but if you need tutoring over there from the STEM lab, that can be arranged. See Dr. Briggs for that. Dr. Davis, the academic dean, coordinates the Space Center tutoring. And Dr. Briggs does the STEM lab on the Birmingham campus, Birmingham West campus. And downstairs, I can't remember the guy's name right now, the Space Center's down there, and he's there. But Ms. Hollins does it up here. She's the coordinator up here, and Mr. Harris is coordinator on the Birmingham campus for Student Support Services. Okay, now, let me tie that in with this. Since we've had 2 quizzes and a test, I was reviewing things over the weekend, and it was rather bizarre, okay? More than half of you, in fact, most of the ones that are in here, have turned in everything. A few of you are still working on some. And I had scores for you on 2 quizzes and a test, or at least 1 quiz and a test. A few of you, just the quizzes, not the test yet. But then, not quite half the class, maybe a third of the class, it turned in nothing. I mean, I didn't have a quiz, I didn't have the test done, nothing, and a lot of them weren't in attendance. So I'm preaching to the choir now. Y'all are here, and you usually are here. But a lot were not. So I went on and did the midterm, even though it's not midterm, the academic progress report. And just let Ms. Herndon's Dr. Herndon's office know that a certain number of students were, I didn't have any materials yet, and the term is moving on pretty fast. We're going to be at midterm in about 2 weeks. So I wanted to get that in early. So if you are contacted by them, it's because at the time I sent that, I didn't have material for you. But a few of you have turned things in since then, so I appreciate that. But they'll just help you see if they can help get you tutoring and that kind of stuff too. All right, now let's go back to this. This week is our homecoming week. Okay, I guess you've seen flyers all over campus. Today, now this is already passed, but they just sent me this today, that the financial faculty staff workshop, financial information faculty staff workshop on this campus was at 10 to 11:30 this morning, and the faculty staff dining room, we're already over. Birmingham campus was also this morning in Thelma Catlin Auditorium, which is in the library building. Tonight, though, is the basketball game, Lawson State versus Sneed State at Spirit Night, so please wear your Lawson State colors and attire. The women's game starts at 5:30, and the men, I think, is at 7:30. Arthur Shore's building, which is a gymnasium on the Birmingham West campus. So that's going on there. Now that's just one of many events that are going on. Tomorrow there's scholarship and transfer information. I, 10 o'clock in the faculty staff dining room on this campus, and 10 o'clock in the Space Center in the Leon Kennedy building on the Birmingham West campus. There's a comedy show tomorrow evening, 4 o'clock, and that will be in A.G. Gaston Auditorium on Birmingham East campus. Wednesday, Name That Tune in the cafeteria here on this campus is at 12 noon, and More Than History, 12 p.m. in the ACAT Auditorium on the Birmingham West campus. On Thursday, there's a cookout on both campuses, 11 o'clock. As far as I know, free food, usually hamburger, hot dog, chips, that kind of stuff, drinks, that kind of stuff, Coke type drinks. Okay. That's Thursday, the cookout. There's the Cougar Choice Awards. That's at 5:30 in the A.G. Gaston building on the Birmingham East campus. And Friday is back to the 90s, Party with a Purpose. Shelter items, blanket, non-perishable items, toiletry items. Bring those 7 to 9 p.m. in the Leon Kennedy Center cafeteria of the Birmingham West campus. And then game day Monday is next Monday, 1 week from today, the homecoming parade, pep rally, and at 4 p.m. at the gazebo in front of the gym, Birmingham West campus. And then we'll be playing Gadsden State Community College, the women playing at 5:30, the men at 7:30. Okay, I think that's just about everything. Lots of stuff starting today and going through next Monday, homecoming. Does anyone come in since I called roll? Oh yeah, I saw you. Tiana. Okay. Any questions on anything before we get started? I didn't mean for the announcements to take that long, but this is a pretty busy week coming up. So I wanted you to know about it. Yes? Right. Okay. You can make it up anytime during my office hours. Now, have you turned in the quiz? Okay. Have you finished it? And so anyone who needs to take a test, I'm available right after class today and Wednesday as well, from 3:15 till around 5:15. So you got plenty of time then. If you have a class then, or that's just not convenient for you, tomorrow and Thursday from 10:45 in the morning till around 5:15. Okay? That will work better for you? Okay. Any specific time in there?
No, so you're right out of class at 10:30. I got an interview.
Okay. Okay, well, I get out at 10:45 here, and I'm in this room. So either come see me here or my office is in 265 across from the orientation classroom. Okay. And then most Fridays, I'm on the Birmingham campus. Finally, I should be there this Friday because I don't have a treatment. So I've had treatments the last 3 Fridays, and they're going really well, but they just wear me out. I mean, this week has not been as bad as some earlier weeks, but the last 2 weeks. But let me see if you did. Yeah, I think you didn't. Okay. The old gray cell way, what it used to be. All right. Any other questions before we get started where we left off today, or last time? Okay, we're in chapter 11, which is graphs of linear equations, and we're not going to do the inequalities part, in 2 variables, and we're in 11.2, just about at the end of that one, example 7, and that's where we'll begin now from current slide. And again, they've done this, like I said, this is my first time teaching, well, I thought we were going to start from current slide, from this text, and I don't understand why example 7 in the text is different from example 7 in the on the slideshow. Most books, they correlate. I don't know why they don't here. Okay. Now, for some reason, it's... Okay, we did that one. All right. Now, this is not the same one that's in your text. We'll do this one first, and then we'll come back and do the one on the text. Okay? Unless you'd rather do the text first, we'll do this one second. Any preference?
We did this one.
Oh, we did do it?
Yes.
Oh, okay. Well, maybe that's why I was stopped where I had. Yes, I remember now. Okay. Had we done the B part? Okay. The B part is write the information from part, well, I'm sorry. Write the information from part A as 2 ordered pairs and use them to graph Bob's cost equation. Did we graph it? Okay, yeah, that's where. So I was on the right slide. I had put my mark in the wrong place in the text. Okay, here are the 2 pieces of information. Let me get my pen set up. Okay. Use Bob's cost equation to determine his cost if he sells 1,000 bagels next month, and if he sells 4,000 bagels next month. So this will be what they're wanting us to graph. Well, that's 1,000 bagels. That's the independent variable, the X. We calculated the cost, $3,200 and $5,500, $3,250 and $5,500. That was the dependent variable. So this is our XY pair. And when it's not Y, it's C. And this is our second XY pair, or XC pair. So on the horizontal axis, we'll do 1,000 and 4,000. Horizontal axis, the 3,250 goes with the 1,000. 5,500 goes with the 4,000. Evelyn, right? Yes. Okay. All right. Anyone else come in since I called roll? Okay. Now, I'll flip back and forth because I don't remember these things too well. Have a really good memory. It's just short. Okay. So let's see what we do. Write the information for part A as 2 ordered pairs. The first of those was 1,000 is the independent variable, and 3,250 was it? Is that the dependent? The cost? Yeah, 1,000 with 3,250, and the second ordered pair was what? 4,000, 5,500. Now, I'm not putting the dollar signs in there because it's not all that important, but use these 2 ordered pairs to graph Bob's cost equation. All right. Now, when you go to graph, it's a good idea to pay attention to what numbers you're dealing with. Notice, what can you tell me about all 4 of those numbers there? First thing you might notice about it. Second? Yeah, they're big numbers, okay? More than 1,000. This one's right at 1,000. What else do you know about them? And this is included. They're all positive. So when you do your graph, there's really no reason to include negatives on either the horizontal or the vertical axis. So do your graph like this. There's a vertical part, there's a horizontal part. Okay? And as you already pointed out, you got some pretty big numbers here. Now, which ones goes horizontally and which one goes vertically? The 1,000 and 4,000 is horizontal. So let's just take that horizontal axis and split it in 2 and call this 2,000 bagels. That would make this 1,000 bagels. And that would make this approximately 4,000 bagels. And you see mine's sort of messy, and that would be 3,000 bagels. Okay? There I've got my independent variable, number of bagels. Okay? You can even name that your bagel. B-A-G-E-L-S, right? Okay. That's what we're labeling on the horizontal axis. Now, on the vertical axis, what do we put there? Okay, this is going to be your cost axis. Okay, and in order to keep this sort of relevant here, I know this seems a little bizarre to say it this way, but these are costs in dollars, and you see your minimum here is $3,250. So let's just, and they do this in the text, but it's different data, let's just do a sort of squiggly line here and call this bottom down here $3,000. We're not going down to zero. There is no zero here. If you go back here, you see his cost is going to be $2,500 whether he makes a single bagel. Remember, that's the fixed cost. He's going to be that. So there's no reason to take up vertical axis with 0 to 2,500. So you could have set this to be the 2,500 because that's going to be the minimum amount you could do. But I just did it like they did in the book and went to 3,000. Now, I know it'll be messy, but let's put our 6,000 up here. And certainly we don't reach 6,000, but we come close to it. Okay? Now these are costs. And what's in between 3 and 6? You got both a 4 and a 5. So let's call this 4,000 here, and this 5,000. This is just how I go about scaling things. Try to even them up there. And the 3,250, this would be 3,500, right? 3,500. 3,250 would be right in between. And that's when he had 1,000 bagels. So there is the first point on our graph. 1,000 bagels with a cost of $3,250, right there. Okay? Now the 4,000 bagels, way on that end, is going to be 5,500. Well, 5,500 is directly in between 5,000 and 6,000. So extend that over here, over the 4,000, and there is that one. So connect the dots, okay? And obviously, okay, I don't draw straight lines very straightly. So it's going to be something like that. Now, if that had intersected properly here, that would have intersected at 2,500. Because at 0 bagels, his fixed cost would have been 2,500. But that supposedly straight line there would represent his cost equation. And remember, we said we're using a linear equation to model the data. We did that last time. This is the graphing of it here. All right. Any questions on that? Okay. Now let's do the one in the text. And I don't know where I'm going to find room to do this. Okay, let's do it here. That's about the most white space I have anywhere here. The amount of credit card debt, this is really scary. Y, so credit card debt okay, that's going to be the Y, which is usually the vertical axis. Let's see if that turns out being the case here. In billions of dollars. Okay, billions of dollars can be modeled by this linear equation. Y, credit card debt, in billions of dollars is equal to 32.0x plus 684. Okay, there is our linear equation. Okay, now this was between the years 2000 and 2008. So x is, I'm going to write it this way, between 2000 and 2008. Okay, so this is a little bit of old data, but that's about what we had. Okay? Now, however, X is not 2000, 2001, 2002, 2003. What they have X being is 0 is year 2000, 1 is year 2001, 2 all the way up to 8, which would be represented 2008. So those are your values for X. Not 2000 or 2010 or 2007 or anything else. They're years 0, 1, 2, 3, 4, 5, 6, 7, and 8. Year after 2000. Okay? So that's where we're starting here. Year 0 represents year 2000, year X equal 1 represents 2001, and so on. Now it says here, use the equation to approximate credit card debts in year 2000, 2004, and 2008. So when X equal 2000, what would you then think the credit card debt would be, which is going to be Y?
684.
It's 684 because you put in a 0 for the X, so you have 0 plus 684, but this is billions of dollars. This is scary, isn't it? That would be what the answer is. Going to be a lot shorter, and from now on I'm just going to write billions. $684 billion. I just wanted to see what an enormous number that was. Okay, how would you do that for X equal? I surely shouldn't be saying that. For year, let's call it year. Let's call this year. Okay, year 2004. What would be your credit card debt that year? What would that be? Okay, it would be 32.0. Now, I can't really say why they're putting the 0.0 in there. It's fine, nothing wrong with it. Times 4, so our X is going to be 4. Here the X was equal to 0. Plus 684. Okay? And what would that be? Credit card debt, year 2004 is what?
812.
I can't.
812.
812? $812 billion. Okay. So I'm not going to write all those digits. Wanted to the first time just to show how big that number was. $812 billion. Okay? And then in 2000 year, 2008, what would be X be then?
940.
Okay, X is equal to 8. So your Y, your credit card debt in 2008 would be 32.0 times 8 plus your 684. Okay, I'm taking your word for it that you're punching your calculator right. And what did you say it was? 940 billion dollars. Okay, wow. Okay, almost $1 trillion of credit card debt in the year 2008. Now, this has really nothing to do with this question, but it does ask you to do something. What happened around 2008? Anyone remember? We had a market crash. We had a fairly major recession that set in that year. My guess is the reason they only did this 2000 to 2008, it was probably like this. I'm guessing after 2008, it went something like that. Because a lot of people were unemployed or underemployed, and a lot of them probably started living off the credit cards. What had happened up till then, they were putting so much equity into their homes, and that wasn't realistic, and it turned out being that the housing market crashed. So then they couldn't borrow on their homes anymore, so they had to borrow with the credit card debt. So that's my guess of why this equation here. I bet you when that changed to 2008, whatever, your 684 may have changed, but I bet you the 32 changed to something probably pretty close to 45 to 50. That slope went way up. Now, since then, it's probably evened back out to something, a slope of about like this, but I don't know if people have gotten that credit card debt paid off yet. But these are real life type situations. This isn't just made up things for math. This is really how we use math. Okay? And so that's the A part here. And yeah, we got the same answers they did, right? In fact, I'm wondering if that's where he got. No, I'm sure he actually did the calculation. Let's do the B part. Write the information from part A as 3 ordered pairs. Use them to graph the given linear equation. Okay, well, what I'm going to do is erase all this, and because I've got it in the book here, and I'll bring it back up then. So let's do, and again, all positive numbers, so we only need that first quadrant of the Cartesian coordinate system. Okay? And what are, on a horizontal axis, what are we representing there? Years, and going from where to where? 0 to 8. So let's put the 8 down here. This is years after 2000. That will put my 4 somewhere about there. That will put 2 somewhere about there. 1 somewhere about there. 3 somewhere about there. 6 somewhere about there. 5 somewhere about there. And 7 somewhere about there. That's how I do my graphing. Just split it up best I can. Fairly evenly spaced. Not exact. Not very straight lines and stuff like this. Now, what are the debt numbers we had? And again, you'll see that we never got down to 0. When the last time it was $0 credit card debt? Probably the year before they started having credit cards. Okay, didn't happen. So let's go back and look. Oh no, I've erased it. I'm sorry, I forgot that. Sorry about that. Okay. I was going to look in the book. 684 was the first, so let's just start 600 here as our base number, okay? And what we got up to was close to $1 trillion. These were in billions of dollars, so let's make it 10, yeah, 1,000 billion is 1 trillion, so that would be 1 trillion. So halfway between 6 and 10 would be 800 billion, and halfway between 6 and 8 would be 700 billion. Halfway between 8 and 10 would be 900 billion. So that's what we're going to be plotting here. And in year 2000, what was it? Okay, it was 684, right? So that's going to be 650, so 675 would be here, so 684 would be somewhere about there. And that was year 0, year 2000. Okay? 2004, what was it up to? 812 billion. Well, there's 800 billion. There's 850 billion. 825 billion. So 812 is going to be just about midway between 800 and 825. So let's put it right about there. Okay? Then, at year 8, we were up to $940 billion. Well, here's 900. There would be 950, so it's just going to be a little below 950, and that's going to be something about like that. Now, if I could draw a straight line, which I can't, it would be yuck, like this. Now, in reality, I shouldn't draw anything back here because we really don't know what was happening there. But the odds are it was probably trucking along pretty close, okay? So I don't mind going a little bit there. This would just be year 1999, or something like that. I bet you that's a pretty good fit. Now that past 8, I probably shouldn't have done much then because sometime past that, it probably skyrocketed because of the recession. But the rest of this, that's pretty good. Ugly line, okay, I admit that, okay, but you get the general idea, right? That wasn't meant to show fluctuation, it was just that I can't draw. Okay, so, any questions there? Now, the one in the book has a C part. It says, use the graph and the equation to approximate credit card debt in year 2002. Okay? When you're 2002, where would I go on the graph? Go to the right 2 and go up until I intersect the graph. And then I come over here, horizontal line, and that looks like if this is 700 billion, 800 billion, that'd be 750 billion. I'm going to guess that's about $730 billion in 2002. And it's 748. So the graph gives you an estimate. The equation gives it exactly. Well, it's an approximate anyway, but the equation was y is equal to 32.0 x plus 684, right?
Yes.
And when you plug in y for x for 2, because this is 2002, that would be 64 plus 684, which would be 724. Is that what you said? Yeah. And we estimated 730, which is not bad. I mean, just making a guess. Okay. So, see how it works? Graphs can give you a good kind of bird's eye view, first estimate. Your equations give you a bit more precise estimate. Your graph can give you a, look across there, that's about 730, about 724. Not far off, okay? And that would be, remember, this is in billions of dollars. Okay. I'm about as cheap as they come. And when my wife and I got married, she was carrying not a huge amount of credit card debt, but she had some. And it just gritted my teeth to see credit card debt. Because at the end of every year, then there'd be a certain amount there of how much interest she had paid that year. And, when you first get married, you have to be a little careful about it. So what I did, probably not very nice, but I said at the end of the year, and we saw the debt, and she was, she knew I didn't carry any. And I said, let's just say she had $200 credit card debt that year, which isn't much. I mean, really it's not. I said, well, and she said, I paid it all off. I paid it all off. I said, yeah, I understand that. But let's think about it. At the end of the year, you paid them an extra $200. If we had paid it all off as we went, you could have had $200 more to spend on buying things. And she started zeroing that credit card every month that she possibly could. And we still do that. Unless some really major expense comes up, we try to zero it every time. Because we don't want them getting any of our interest, so she can buy more if she wants to without having to do that. Now, I know that people in certain circumstances just don't have that luxury, but we were fortunate to be able to do that after a while. All right, homework exercises 11.2. There's a couple of concept checks there. Let's fill in the blanks here. A linear equation in two variables can be written in the form of ax plus blank is equal to blank. What would go in that first blank? Okay? Not bx, two variables, so you'd have to have by is equal to c, just some constant c, where a, b, and c are real numbers and a or b are not both blank. It doesn't make a lot of sense if both a and b were blank. Zero! Because if A and B were both zero, then C would have to be zero, wouldn't it? That's not a very interesting equation. 0 plus is equal to 0. Okay, yeah, not very interesting. That just states a pretty obvious fact. Okay, so as long as A and B are not both 0. Number 2, the graph of any linear equation in two variables is a straight blank. Line, exactly. Linear, the first four letters are line, L-I-N-E. Every point on the line represents a blank of the equation. Say that again? Point. A point. That would be a very good thing. A point, an ordered pair, but they put A there, so I think point is what they're looking for. Could be a solution to the equation. You know, that would be another word that would fit there pretty nicely. So let's look at number 3, concept check. Match the information about the graph in column 1 with the correct linear equation in column 2. Now, some of you don't have your books here, right? So I will do the columns here. I'll try to do them quickly. If I can get the machine to cooperate. Okay. Here is column Roman numeral 1, and here's column Roman numeral 2. The A one. The graph of the equation has a y-intercept of 0, -4. Okay? The A over here is an equation that's 3x plus y is equal to -4. Okay? Here's little b over here. The graph of the equation has 0, 0 as an x-intercept and a y-intercept. Graph has 0, 0 as x and y intercepts. This is on page 746. Number 3 near the top of the page. And the b here is x minus 4 is equal to 0. Okay? The little c here says the graph of the equation does not have an x-intercept. Graph does not have an x-intercept. And the capital C here is x is equal to y is equal to 4x. And little d here says the graph of the equation has x-intercept of 4, 0. Graph has x-intercept of 4, 0. And the d over here is the equation y is equal to 4. Okay. Now what they're asking us to do is to match this description with one of those equations. Little a, graph has a y-intercept of 0, -4. Which of those seems like it would match? Say that again?
X minus 4 equals 0.
Okay, now let's see if it does. That would be a pretty good guess, except when you put a 0 in for x, what would you have?
Minus 4.
Equals 0. Think that ever happens? If so, I'll owe you $4 but I'll owe you $0. Okay, I'll go with the 0. Okay, never mind. All right, so I don't think it's B.
It is C.
Is which?
C.
D?
He said C.
C. Okay, I can't hear well. Well, if we put a 0 in for x, what do we get here?
0.
Y is equal to 0. No, that doesn't work. This is what we call multiple guess. I mean, multiple choice. Never mind. Okay. Which one do you think this might be? We ruled out B and C. A. Let's try A. If you put a 0 in for x, what do we have?
0.
Yeah, 0 here, but then we have y is equal to -4. There's your ordered pair right there. Okay? So little a matches big A. Don't expect the others to be that way, but let's see. Number B. The graph has y-intercept and x-intercept of 0, 0.
C.
Which one's C? I believe you're right, because if we put a 0 in for x, what do we get for y?
0.
0 and 0 for x, 0 for y. That's your x-intercept. It's also going to be the y-intercept. Okay? So little b matches capital C. How about little c? The graph does not have an x-intercept.
D.
Second,
D.
D. Why is that? Because y is equal to 4 is a horizontal line. It never is 0. So it can't have an x-intercept. It doesn't ever intercept the x-axis because y is always 4. Okay? Now, number D. The graph has an x-intercept of 4, 0. Any that fit that?
B.
You say B as in Bravo?
Yes.
Yes. Okay. Let's see if that's true. Well, what would happen if we added 4 to both sides? What would we have then? X equal 4. Don't forget to add. X equal 4. Well, guess what? When y is 0, it would be 4. When y was 17, it would be 4. When y is -2/3, x would be 4. Okay, so sure enough, when y is equal to 0, x is 4. Yep, that's number B, or letter B. Because x is always equal to 4. That would be a vertical line, by the way. X equals 4. So 4, 0 would certainly be the x-intercept for that. What would be the y-intercept for that? Number B. Okay. Well, when x is the y-intercept is where x is equal to 0. You put a 0 in here, and you get -4 is equal to 0. We did that, remember? Can't happen. That means there is no y-intercept. Vertical line like this over at 4 is never going to cross the y-axis, ever. Because this is vertical, the y-axis is vertical. They never, ever touch. Okay? Good deal. All right. One more concept check. No, two more. Which of these equations has a graph with only one intercept? Let me erase this so I can write these equations down, because not all of you have your books with you today. Okay? Here are the 4 equations. A is x plus 8 is equal to 0. B is x minus y is equal to 3. C, x plus y is equal to 0. And D, y is equal to 4. Okay? The question is, which of those 4 equations has a graph with only one intercept? And actually, it can be more than one. Second?
D.
D certainly has only one intercept, and what intercept is that? Second?
Y equals 4.
Y, yeah, 0, 4.
0.
Whatever x you put in there, the y is always 4. So that only has one intercept. Is that the only one with only one intercept? A only has one intercept. And what intercept is that? Say again? Okay, here we'll couldn't make any better.
I'm making sure I give you the right answer.
Oh, okay.
Could be negative 8.
Say again?
Could be negative 8.
Yes, what would be negative 8?
X.
X.
The x-intercept would be negative 8. Negative 8, 0. Intercepts are always ordered pairs. Negative 8 for x and 0 for y. Okay? So that one only has one intercept, an x-intercept. D only has one intercept, a y-intercept. Any of the others?
C.
C, why?
Because you put anything in there.
When you put x equals 0, what do you have? Y is equal to 0, so that'd be 0, 0. If you put y is equal to 0, what do you get? X equals 0, so it's 0, 0. That's the only intercept it has. Anytime the C is equal to 0 and your AX plus BY is equal to 0, you have the line that goes through the origin, and that's your only intercept. So, actually, A, C, and D all have only one intercept. C, both intercepts are the same number. The other two, they don't have but one. One has a Y, one has an X intercept. All right. Number 5, concept check. Identify the intercepts of each graph. All coordinates are integers. Okay, yuck, I'm going to have to draw this one. Am I not? Yuck, yuck, yuck. I'm going to do something. Is this going to get me in trouble? Let me try this. Let me try this. This is not going to be pretty, but all right. All right. I already had this on hand here. Number 5, you tell me what 2 points, some of you who have a book in front of you, what 2 points they list for this the graph, okay? Now 4 is just a number. I need an ordered pair.
4.
Say again?
4.
Okay. You're giving me 2 numbers. Do you mean that as a...
4x, 4y.
Okay. All right. Let's slow down a minute. I think this is... Ooh, let me get... Well, they drew in red. I'll draw in red. There's a point, and there's a point. Okay? That's 2 different points. Can you give me the... I'll change back to dark here. What's the ordered pair? Which one you want to do first? The lower one or the right one? Upper right one? Pick one. Upper right. Give me that point, the coordinates for that point. 4, 0, exactly. Okay? And on the other one? Nope. -4, perfect. Okay? And the line that went through this, though I can't draw very nicely, is, I'll give it my best shot here. It's a lot easier to draw lines when you have grids to go on. There would be about that line. Okay? Now, the question was, identify the intercepts of each graph. Can you identify the intercepts of that graph? Say again? They're both intercepts, but I want to know which is which.
You said which is what?
Which is which?
That's...
Say again?
I'm not getting the question. What's the question?
Okay. Daniel said they're both intercepts. And I said, well, which is which? There's 2 types of intercepts. What are they? Say again?
X-intercept.
X-intercept and Y-intercept. Okay, which is which of those?
Y is 0 to -4.
Exactly. Now that was said absolutely correctly. The point is 0, -4. That's the intercept, and it is the y-intercept, and therefore
The x-intercept would be 4 and 0.
the x-intercept is 4, 0. Say it as an ordered pair, and you got it. Okay? Now,
Basically, you just want the ordered pair. You don't want just the number on the line.
that's correct. Most of the time, every point on the graph should be expressed as an ordered pair. Even if one of those orders is 0, and one of the pair is 0, still express it. Now, quite often we'll say, oh, the y-intercept is -4. Well, I understand what that means, but really the y-intercept is the point 0, -4. Y-intercept, because any y-intercept, the x-coordinate has to be 0. Okay? So help me do number 6. Anyone that's got a book?
-5, 0.
Ah, excellent. That looks like 1, 2, 3, 4, 5. -5, 0. And
Then you got 0, 5.
it looks like 0, 5. 1, 2, 3, 4, 5. 0, 5. Okay, again, I'm going to do my best to get something that looks sort of like a straight line through those 2 points. Okay? And it says, identify the intercepts of each graph.
Y would be -5, 0. I mean, that should be -5, 0.
The x-intercept? Okay, I'm going to go back. Yeah. Okay, the x-intercept is -5, 0. Perfect. And
The y is 0.
y-intercept is
0, 5.
0, 5. Perfect. Okay? That was number 6. How about number 7? Help me plot the 2 points. What are they?
-2, 0.
-2, 0 is right there. Let me go back to red. -2, 0 right there. And
0, -3.
0, -3. That's down here. So let me identify those. You just told me what they were. Yuck. Where's my pen? Okay. Yuck. All right. That will be -2, 0. And this one was
0, -3.
0, -3. Perfect. Okay. I'll go back to red again and draw. Ooh, this is going to be harder. What I like to do is give me a few points to aim toward. Okay, we'll talk about how we get those later. Okay, there's my thing there. And you identify for me what your intercepts are.
H is -2, 0.
Is what? That's the x-intercept. Where is my pen? Okay. Okay. This will be the x-intercept. Everybody see that? And this will be the y-intercept. Is 0, -3. All right, this is getting awfully crowded, but let's see if we can fit number 8 in here too. Okay? Give me a couple points there. 0, 3, that looks like 1. And 4, 0. Okay, there's 4, 0 already. So this one was 0, 3, and this one was 4, 0, already listed. So let me see if I can plot those values. Oh boy. I don't think I can do much with that. Okay, it's going to be something like that. Okay, and you tell me what's what on that one. Is your y-intercept, and that's your x-intercept. Perfect. Way to go, folks. All right, those were the concept checks. Let me give you the homework. Do any of the odds 9 through 13. Oh wait, this one does them all. Do any of the ones 9 through 14. Okay? Now, does anyone know what the little circle with the arrow, does that mean that's something that you get in My Math Lab? Yeah. If you are using My Math Lab, you can find 9 and 11 on My Math Lab. You see that thing at the top? Okay. Then do any of the ones 15 through 20. And what does the GS stand for? Does anyone know that? Graphing Simulator? I don't know.
It's in the bag.
It's what?
It's two different answer keys, I guess.
Oh, I see. Okay. I see. The one in the green, is that the GS? And the other one is your solutions. Okay, so they have some answers and some solutions. Okay, glad you understand this. Okay, then do any of the ones from 21 through, whoa, look at those, 21 through 40. Okay, and in those 31, 33, and 35 appear to be in My Math Lab. And here we have 39 is colored. I don't know what that one means. Okay, beats me. Then do 41. It has 4 parts to it. And here's another concept check. What is the equation of the x-axis? What is the equation of the x-axis? The horizontal axis there. What would be its equation?
0, 0.
That would be a point at the origin. I need an equation. Oh, and by the way, okay, let me say this before anyone makes any more errors on it. And I kind of hate to say it now because some of you haven't taken the test and some of you have. But look, when they ask for an equation, what does every equation have in it? An equal sign. If it doesn't have an equal sign, it's not an equation. Now, if something is asking you to simplify something, don't go throwing equal signs in it, okay? You're not allowed to do that. The book or me or somebody else has to decide whether it has an equal sign or not. You can only solve an equation if it has an equal sign. If it's simplify an expression, expressions generally don't have equal signs. So don't be solving expressions that don't have equal signs, and then I don't know what you'd be doing with equations that do. So, but that led to it. The question was, what is the equation of the x-axis? And you said 0, 0, which is a point, an ordered pair. That's not an equation. An equation has to have an equal sign. So give me an equation for the x-axis. The x-axis. X equal 4 would be that line right there. Oh, x is always 4 on that line. Tell me we're out of it. No, we're not. We got 5 more minutes. Okay, you started packing too soon, didn't you? Okay. What's an equation for the x-axis? The horizontal axis.
0, 4.
Okay, that is an ordered pair, a point. An equation has to have an equal sign. 0, 4 would be this point right there, a point, and that's not even on the x-axis. X equal y plus 2, is that what you said? Okay. What I would do with that, x equal y plus 2, if I wrote that down, I'm going to write it down. In fact, is it all right to erase all these? Because they're getting a little messy. Okay? You said x equal y plus 2. Now that, sure enough, is an equation. Okay? Now, what if I'll ask the one that's going to come out okay first. What if y is equal to 0? What would that equation give you if y were equal to 0?
2.
X equal 2, okay? Well, sure enough, that's on the x-axis. But what if I said let x equals 0? What would you have then? Y is equal to negative 2. Well, x equals 0, y is equal to negative 2 would be down here. Those 2 points, one of them's on the x-axis, the other isn't. So therefore, I would say, nope, that's not an equation of the x-axis. What would be an equation of the x-axis? Okay. Describe the x-axis for me.
X equals 1.
Is what?
X equals 1.
X equal 1 would be this line right here. Because x is always 1 here. X equal 4, that you said before, is always there. X is always 4 there. Say again? Y is equal to 2 would be here. But at least we're getting better. Which looks more like the x-axis? This, that, or this?
X equals 0.
What? X equals 0 would be that one. So close.
I wait for you to tell us.
No, you tell me. So close. What is the equation for the x-axis?
What is the place? But all the shit with y-axis or x-axis.
Yeah, this is the x-axis. What's this equation?
X minus 8 equals
Say again?
0. X minus 8 equals 0.
X minus 8 equals 0. If you said that one, let's do it. I'm going to erase these because they didn't work. Okay, you said x minus 8 equals 0. Is that what you said? Okay, I'm going to turn that around and say add 8 to both sides, right? That's legal in most states, right? That would give you x equal 8. X equal 8. 1, 2, 3, 4, 5, 6, 7, 8. You got me off scale here. That would be out here somewhere, but it would also be here and 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 here. Okay, x is always 8 there. Doesn't look like the x-axis to me, right? Now, what was the one I think you said that looked pretty close to the x-axis, just not quite right?
I said y equals 2.
Y is equal to 2. That would be up there. Now that looks closer to the x-axis than these do. So what would that be then? Y is equal to 0. You're right. You don't go up or down with y. Y is equal to 0. There it is. The x-axis is y is equal to 0. Y is equal to some number, k or whatever. That's going to be a horizontal line. Guess what? The x-axis is a horizontal line. So it's y is equal to something, and what's its value always? Y is equal to 0. Very good. All right? What is the equation of the y-axis?
X equals 0.
Yes, x equals 0. Excellent. Okay. All right, that was your concept check there. Oh, goodness, I missed concept check 41, but we're out of time. So let me just assign the rest of them. 43 to 46 and 47 through, whoa, goodness gracious, 54. You don't have to do them all, do some of them, okay? I really thought we'd get further today. Next time we'll start with 11.3, okay? Now, 11.3 is a fairly long section, and we're not going to do, no, I don't know why we're not doing 11.4. I think we will do 11.4. I don't think I have them on my slide set, so I'm going to add that. 11.5 is the one we won't do, so I'm going to add 11.4. I don't know why I didn't have it on this, but I'm going to check and make sure I've assigned it to you too, so on the PowerPoints. Good deal. Any questions? All right, 11.3 next time. Good deal. I appreciate this group, great attendance, okay? The others, where are they? Okay. Yeah, I don't know how I messed it. I think it must have been when I was saying I put an 88 down there for you. When I went back and looked, it's 83. I don't know where I got the 8 from, so I want to let you know. It wasn't someone's messed with Blackboard, it's I messed up.
Okay.
Yeah.
Thank you.
All right. Yes.
I'm ready for my test.
What's that?
I'm ready for my test.
Oh, you want to do it?
You got the schedule for the Birmingham Study Lab campus.
Okay. The tutoring places?
Yes, sir.
Okay. The Space
I already
Center?
know what an investment is.
What's that?
I already know what tutoring labs are. Investment. I need to want to graduate.
Okay. And you want the times? Is that what you're asking for?
Yes, sir.
Okay, that's for the, you want to take pictures?
Yes,
Okay.
sir.
You can take 2 or 1 or whatever. All right. Get your test. Here we go. Well, that's my original. Well, it's not either, is it? I don't know how this happens. Okay. It's not my original. There's my original. There it is. Okay. Okay. It's printed front and back. Okay. And you want to do it in here? Okay. Hey. I'm sorry? This morning and this afternoon, but I saw your email, and that was right before I came to class. So
Okay, so you haven't had a chance to look at it?
Right, well, I looked at the first part, and it starts off talking about the technical school, and then it jumps a few years, first president, thus and so, but it skips a whole bunch of years there. Did the technical school not have a president, or was that after it was merged?
Who actually did that part?
I will tell you that. I said, that just doesn't sound like crazy.
Most of it.
Yeah. Okay. Okay. I'll take a
I just
look.
went back through and whatever I could add.
Yeah. Okay. There were just a couple of things like, well, that's as far as I got to read. I started doing it. I don't have time to do it. Huh?
I was wondering if we really needed all of that.
That's what I sent to you, or I sent it to him. It was a paragraph, you know. I didn't.
It was like almost a whole thing on the library, but it wasn't asking about the library. It was asking about our students using the library.
Yeah.
And I think it was science.
We used to have an expression in the Navy, or at least a guy I worked with. He used this. He said, if you can't dazzle them with brilliance, baffle them with BS. Did I say that? Yeah, it seems like that's a lot of what we do for SACs and everything else. Yeah. And, yeah. So, yeah, I'm going to try to, she's making up the test now, so I won't be able to go down to my office, but maybe I can work on it up here some.
Basically, he just went ahead and put it out there on
Right.
the drive, so whenever you finish, you just swap out.
Okay.
Take that one.
Because I don't know what to put in its place, because it started, the first sentence was about when on the technical school or whatever it was, and then the next sentence was the first president of the institution, and it was like 15, 14 years later was blah blah, you know, and I went, and in between. And it didn't even say it's a new thing, but then the next thing said it's name change, and that year matched name change here. So I think that's the first president of the new combined college, is what I think it was. But it just didn't read really well. I said, I think this is Tracy. Okay. That's what I'm guessing. And maybe not all the sentences copied or something. Yeah. Yeah, that's about typical of our webpage. Or human resources. I said it again. Okay. I'll try to get to it.